Hello, geometry students. I am looking at Unit 4, Congruent Triangles, Homework 1, Classifying Triangles for Mr. Fry. It is due on Monday, the 14th. Let's get started. It says classify each triangle by its angles and sides. So, taking a look at these, we have two sides that are congruent. That means it's isosceles, and we have all of our angles are less than 90, so it's acute. I did number 2 also just because I forgot I'm only doing odds, but here's number 2 for you. All of the sides are a different length, so that means it's scaling, and we have a right angle in the triangle, so it's a right triangle. Number 3, regarding the sides, all the sides are different. That means it's scaling. Regarding the angles, we have one angle that's greater than 90, so it's obtuse. Number 5, regarding all the sides, these two are the same, so that's isosceles. And then we have a right angle, so that means that is a right triangle. For number 7, all my sides are equal. That means it's an equilateral triangle regarding its sides. And then all the angles are less than 90, so it's acute. For number 9, we're taking a look at this diagram, and under these conditions, QN bisects PQR. That's what this is, QN bisects PQR. So that means this is 30 and this is 30. And N is the midpoint of PR, so N is the midpoint of PR, so that means that this is 7 also. So this, I might as well write these in here, 7, and this is a 30-degree angle. Okay, so in other words, 14, 14, 14. So this PQR is an equilateral. That's our first one. All of the angles are going to be acute also because 30 plus 30 is 60. We have 60. That means this one's going to be 60. So it's acute also. PRT is scaling and obtuse. PRT, all the sides are different. And then we have this angle here that 180 minus 60 would be 120. This one would be 120, which is greater than 90, so it is obtuse. That's where we get obtuse. TQS is isosceles and acute. TQS, if this is 7, or I'm sorry, if this is 14 plus 5, that's 19. This is 19. So that means it is going to be isosceles. And we have 76, 76, 28. That makes it acute. They're all less than 90. And then D, we have scaling and right. QNP, QNP. This is going to be a right angle also here. If this is right, this is right. Because 90 plus 90 is that 180, that straight line. So I'll do that. And it's scaling because I have 7, 14, and whatever this is. You could find that out using the Pythagorean theorem if you'd like, but you could just look at it and say it's scaling and right. For number 10, this is the real booger here. Find the measures of the sides of triangle DEF, then classify it by its sides. You have to use the distance formula, the distance between all of these points. So I find the distance, and you're going to have to pause this. I use this formula, the square root of the quantity of x2 minus x1 squared plus the quantity of y2 minus y1 squared. I plug in my I could label these, and I'll relabel these, x1, y1, x2, y2. And I just plug in those numbers here. Remember, when you're subtracting a negative, it becomes positive. And you just work it out. Square root of 90 ends up being 90.49. None of these come out real nice. That's why it's an ugly problem. Just a little over, about halfway between 9 and 10 units. Okay, and EF, I'm going to change these, and these become, so if I'm looking at EF, now I got my x1, y1, x2, y2, and I'm going to just plug in these values for my x2, -2 minus -1 makes it a +1, and so on and so forth. You can see what I've done with EF and go ahead and go through and work this problem out. You end up, should be getting 8.06. Then I'm going to change them again to find FD, and here's FD. You might want to pause that, but I'm renaming these. And here is going to be my, since I'm going from F to D, X1, Y1, X2, Y2. So you see my X2 is 8 minus my X1 was a -2, which is +2. So subtracting a negative, and so on and so forth. Just go through this. I end up getting square root of 221 is 14.87. So all of these are different measures. All of them are different and should be scaling. Moving on to number 11. Number 11, I started it with for you, and you just figure out what the square root of 53 is on your calculator. If you're not sure where the square root button is, it is right here. If you have a calculator like this one, you hit the second in order to access it. You hit the second and then square root. And then you put your number in there. So I'll put 53 in there. You don't have to use the back parentheses. 7.28. So the distance between, and this is going to be, what did I use here? 5, -2, 5, and -3. Okay, so this is actually, let me get rid of this. This is DE. So DE, okay, equals all of this. And it was 7.28. So there's the first one for you. Go ahead and do the same thing, remark these. I started by doing X3s and all that, but X and Y3s, you just rename them each time. So, you know, go ahead and do EF like we did before, and then do FD, okay? And then figure out if if two of them are the same, it's isosceles. If they're all different, it's scaling. If they're all the same, then it's equilateral. All of these are about the same, so I'm going to just do the odd ones. You're to come up with the equations and solve the problems. QRS is an equilateral triangle. If QR is 7 less than twice x, 7 less than twice x. First, I drew an equilateral triangle. It's good to have a little something to look at. RS is 61 less than 5 times x. RS, 61 less than 5 times x. And QS is 11 more than x. 11 more than x. Find the value of x and the measure of each side. Well, it's equilateral, so you find the measure of one side, you find the measure of all sides. And so I took the two easiest ones, the two smaller number ones. I kind of left that one out. So you could do either one. You'll get the same answer. I did this one equals this one. Okay, so these two sides equal because they're equilateral. I solve. I subtracted x from both sides. I added 7 to both sides, and that's why I picked those two, because it's so quick and easy. X equals 18. I substitute in to the easiest one, 18 to this one, plus 11 equals 29. So all the sides measure 29. 29, 29, 29. When you put in 18, any of these, and I checked, you'll get 29. You could check. Number 15, WXY is an isosceles triangle with WX and WY equaling, so WX and WY. And here's what they give us in the problem. I set these two equal to each other to solve for x. I get 23 for x. Now to get WX and WY, I pick either one of these. It doesn't matter, you'll get the same answer. Plug in 23 for your x, and you get 95 as the measure for either one of these. Now this one, XY, is going to be different. I plug in 23 and I get 108. Okay, and so hopefully that helps. And please let me know if you need any further assistance. Zoom in on me.